In this video, we will use factorable and factorial to generate the dataset trend line and trend line polynomial of exponent 0.5 times x squared. So we begin with the Taylor-Maclaurin series sum, which is the summation of a times x to the power 2n, where a can be the factorial, the double factorial, that is 1 over fact double 2n, or factorial, which is 1 over 2 to the power n times factorial n. And the value of n is from 0 to infinity. In this case, we can go as far as 16, which is good enough. Now we continue with the Taylor-Maclaurin series sum coefficient. Start with the factorial. So this array formula. 1 over, there are two parts, 2 to the power n times factorial of n. Then enter. And we use the factorial, double factorial. So array formula, 1 over factorial double factorial of 2 times n. And we still get these answers. These values are the same. Now we can continue with the expansion, which is array formula, series sum of the x values raised to the power 2n, where 2n start from 0, that's 0, followed by 2, 4, 6, 8, so the interval is 2, and the coefficient. You can use one of the two, any one of the two, so we will do the factorial first. And we'll chart this. Insert chart, and we'll use scatter chart. Row 1 is header, and the series trend line, show the trend line, polynomial. We'll try to get to the highest degree, 10. No, it's not possible. Maybe 8. 8 is okay. Then show the equation as, and the legend, position at the bottom. So here's the trend line and the trend line polynomial to the 8th degree. Next, we continue with the exponential function, which is equal to array formula. We start with the exponential function of the x values. And we show the equation. Series, trend line, polynomial to the 8th degree. Use the equation. And here you have the trend line polynomial. And we'll modify it. So this is raised to the power 2. That's x squared. Now that it's raised to the power 2, then we multiply 0.5. So 0.5 times. Now they're all in the same trend line, and their polynomials are the same. Their data sets are also the same. Now we'll calculate this polynomial regression coefficient using Linest to complete the Linest matrix. So begin with the power transpose 0 to 8. And the elements array formula of the x values raised to the power 0 to 8. Now we can calculate the polynomial regression coefficient. So Linest data y, that's for the expansion, and data x. And actually, the function itself, data y and data x. And let's compare. So we have the coefficient for x to the 0, 1, coefficient of x, 0, coefficient of x squared, 0.0499, coefficient of x cubed, 0, coefficient of x to the fourth, 0.131, coefficient of x to the fifth, 0, coefficient of x to the fifth, 0, x to the sixth, 0.0127, x to the seventh, 0, and x to the eighth, 5.78 times 10 to the minus 3. Suppose I change, instead of the factorial, I will use the double factorial. We still get the same results. And the coefficients are the same, and the trend lines are also the same. This completes the use of double factorial and factorial to generate a trend line and data set of exponent zero point 0.5 times x squared in Taylor-Maclaurin series sum and Linus polynomial regression.